So Behringer Crater between Winslow and Flagstaff, Arizona. And it's out in the middle of the desert. There's no erosion out here to fill this thing in. So it happened quite some time ago, thousands of years, tens of thousands of years ago, and the impact created this crater that is a little less than a mile across, about 3/4 of a mile across, and several hundred feet deep. And it turned back the surface of the ground where it hit, pulled back stuff. Debris was thrown in all different directions, all over the place. And this large hole in the ground, for a long time, nobody really knew what to make of it. Because if you're out in the desert and you're approaching the thing, you don't really see the hole. You just see this rim around here, and it kind of looks like a big hill ahead of you. It's only when you climb to the top of the hill, you look down and say, hey, there's a big hole here. But the hill there, was called Coon Mountain, and they had this huge argument over what caused this. Some people were thinking it's a giant sinkhole, except geologists couldn't explain why you had to get a sinkhole in this kind of rock formations. Others thought it was some kind of steam explosion, because clearly the ground had been peeled back, not falling in. And so they thought maybe lava from below came up and hit a pocket of underground water, which turned to steam, made a giant explosion, except there were no other lava flows nearby, so that didn't seem to make any sense. Huge argument over what this thing was. The real clue came from a geologist by the name of Gene Shoemaker. And Shoemaker came to the conclusion that this was a meteorite impact. A large meteorite did this. Actually led a fellow named Behringer to actually buy the land out there. And in the bottom of that crater, you saw these buildings. They had actually tried to sink mine shafts into it because they knew a lot of the meteorites were very rich in iron and thought they'd have rich iron ore out here and make a lot of money. Well, it turns out the explosion decimated not just the ground but the asteroid coming in, and the explosion blew the asteroid bits not buried in the ground but blew the asteroid bits all over Arizona. So this was actually the last place to look. They found bits and pieces in there, but not very much, not enough to warrant the cost of the land. Behringer actually died, without a whole lot of money, left the big hole in the desert to his heirs, who actually kept it. And so it's still a family-owned meteorite crater, and they sell tickets to come see the hole in the ground. School groups can actually get in for free, and we've actually had a field trip that visited this place. But yeah, it's an impact, and Shoemaker was the first one to actually figure this out. He actually died, unfortunately. He actually visited many craters around the Earth, and there was a geological feature in Australia that they were suspecting might be an impact event, and he was on his way there and had an auto accident and died in 1997. The impact was so massive, though, that for a distance of about 6 miles away, about 10 kilometers, so that's about 6 miles from the actual impact, the fireball from the blast pretty much killed everything. Okay, out to a distance of 24 kilometers. So that's quite a bit farther out. So a distance of 24 kilometers out here, you had large animals were killed by the pressure. And then hurricane-force winds out to 40 kilometers. 40 kilometers is about 24 miles. So 24 kilometers would be probably about a dozen miles or so. But this hurricane-force winds out that far, and then blast waves, sound waves and blasts even beyond that. Earth actually has a lot of meteorite craters. And so, for example, we have these double impact craters right here. That's probably from one of these bilobed asteroids that hit and then broke apart when it got here. A lot of things that we now realize are meteor craters, they didn't know were meteorite craters for a long time. They just thought they were just weird circular lakes here. and then water filled them in. You have erosion here. And so these kind of structures right here were later discovered. Here's one that erosion filled it in, and then further erosion eroded away the uplift around it, because the uplift, this ring of stuff thrown upwards by the impact, is all crushed rock and easy to wear away. Some of these meteorite, the ground bounces back in the middle, leaving a mountain peak in the middle of your crater. Some of these are very hard to see because they have been largely eroded away. Some of them are again, very hard to see if you got vegetation around, because that kind of covers things up and fills them in. And so you end up not really seeing all the details that go with this. It's just a big hole, okay, a big circular lake. 2007, a little village out in Peru, a meteorite landed and created a big hole just outside the village. Now this is a big hole by human scale, small compared to those others that I just showed you. But again, things fall of this size on a regular basis. Somewhere on Earth, you're going to get an impact like this practically every year. And now, granted, the bulk of the Earth's surface is water, so a lot of it splashes in the ocean. There have been a couple of times, for example, that a small wave, or like a mini tsunami, is washed ashore, and airliners report dust and debris in the stratosphere. And so most likely this is going to be an impact of some sort into the ocean. So what does it all mean? Like I said before, the chicken was right. Okay, the sky is falling. Now, depending on who you ask, how often do these things happen, okay, and you can sort of estimate the size of the impact here versus, how likely, and they estimate here that possibly, and again, this is from 1989, possibly you can get close to 20 kilotons almost every year. That's atomic bomb size. So this researcher right here, whose data I borrowed, whose graph I borrowed right here, this data right here seems to indicate that possibly you get atomic bomb-sized impacts almost every year. The Tunguska event might be once every couple hundred years. Okay, the Meteor Crater event might be almost once every 1,000 years, and the Meteor Crater itself was quite a few thousand years ago. So there are others that may have fallen in other parts of the world, that we don't know about. Possibly every few 100,000 to tens of thousands of years, there is a monster event that has catastrophic effects across the entire planet. Okay, so this would be like the asteroid PHYS running into us. That'd be in the lower end of this global catastrophic thing. The dinosaur event, we'll get to that in a second here. So that's on the higher end right there. Meteorite craters. This is from a number of years ago, 1990s. I haven't seen a more recent one since then, but this was a map I saw of meteorite craters. What's striking to you is you see the most meteorite craters in North America, in Europe, and in Australia. So why is that the case? Why do you not see very many meteorite craters in South America and Africa and so forth? And the reason is those three places where you see the most craters are where the most geologists live. And so they find meteorite craters more often there. Does not mean that meteorites don't hit elsewhere. They probably hit with the same density all over the place. Texas has meteorite craters. Back quite a few years ago, the Astronomy Club actually did a field trip out to West Texas. We stopped at the Odessa Meteor Crater. So technically it's called the Odessa Meteor Crater, but it's really a meteorite crater. The Odessa crater is actually owned by the city, so it's a city park. So it's actually free to visit. and you can go and visit and tour the hole in the ground. This hole in the ground is almost completely eroded, so that means that as it's completely eroded, you don't really see a whole lot of things. The ground is only just a tiny bit lower in elevation than the surroundings. The surrounding rim that had been pushed up has been mostly eroded away itself. And so it is a circular sort of scar on the surface of the planet. That's not the only meteorite crater that's there. South of there is something called Sierra Madre. Sierra Madre is another remnant crater. What happens is you've got this crater right here, and the crater compresses the ground when the impact comes. When the impact comes in, it compresses the ground, you make the crater, then the ground rebounds in the middle of the crater and gives you this mountain peak sticking up out of the ground. Unlike the Odessa crater, you can't actually visit this. I mean, there's actually a state highway that runs, through the edge of the crater here, and you can see the central uplift kind of off to the side, but it's on private land. So this uplift, and you notice if you look at pictures of the moon, a whole bunch of the craters in the moon have central peaks in the middle, and that's from the ground rebounding from a big impact. Over time, the craters erode if they're on Earth. Remember, that's the main thing of our atmosphere. We have wind, we have water, we have rain. We fill in the craters. Earth gets hit quite heavily. It's a bigger target than the moon. The atmosphere protects us from small things, but the big craters that you see on the moon, we have just as many impacts on Earth, more so because we're a bigger target. It's just erosion fills them all in.